By looking at the points -2, -1, 1, -1/2, 0, 1/2, 1, and 2, we can tell a lot about the behavior of power functions. We look here first, we look here at the behavior of positive power functions, x squared, x cubed, and so forth. And we start with just x squared and x cubed. Our x squared function, well, first place, okay, our x squared function and our x cubed function both go through the point 1, 1. Our x squared function goes through -1, 1, while x cubed goes through -1, -1. And both functions go through 0, 0. And that's obvious if we evaluate the functions at these points. So there are no surprises there. Now let's think about what happens at x equals 2. At x equals 2, x squared is going to be 4, where x cubed is 8. That means that x squared goes up pretty fast here, but x cubed goes up faster. Now this isn't a particularly good graph. This thing doesn't really go up quite as fast as I've drawn it here, more like what we see down here maybe. But that's not particularly well drawn either. At x equals 1/2, we see that x squared is 1/4, whereas x cubed is half of that, or 1/8. Again, that's not drawn very well. This thing looks more like an x to the 6th or x to the 7th function here than an x to the 3rd function. But that's okay. We get the idea, and you should draw these graphs yourself and draw them carefully. At x equals 1/2, then, the x cubed function is lower than the x squared function, and this pattern is clearly going to continue for higher and higher powers of x. Now on the other side here, of course, we have a plus 1/4 here and a negative 1/8 here. But again, we see that the x cubed function is closer to the x-axis than the x squared function, and this pattern is going to continue, as is the pattern of flipping back and forth between positive and negative as we go from even to odd powers. The result is that, first of all, our even powers are symmetric about the x-axis. The odd powers are antisymmetric, where they're up on one side, they're down on the other. And higher powers get flatter and flatter in the region between 0 and 1, or at least in the region between 0 and 1/2. Up to a certain point here they stay flatter, and then to make their rapid increase they have to turn around very quickly. And eventually these things just kind of approach a square function. They just come over here and then turn real quickly and go almost straight up. And of course higher powers will be steeper and steeper as you pass x equals 1. So if we really think about what we're seeing here, it's fairly easy to see how the power functions, at least the positive power functions, behave.